This one is kind of the culmination of everything sections 2.1 through 2.5. You're going to have to use your whole bag of tricks on it. Got to find them all. You got to find them all, not you and your neighbor. You got to find them all. Because this would be very indicative of the type of problem you may see on the next quiz. Which, because of yesterday's FUBAR day, will be on Monday. We review it right before you do it. I don't know why people are so wigged out by Monday tests.
I just don't like Mondays.
I think Mondays are
Monday
misunderstood.
test on Monday, it's just Monday.
I think Mondays are misunderstood.
Yesterday I forgot that it was Monday and I told a customer that it felt like a Monday and they looked at me and
I'm sorry that yours is wrinkly. Harley exploded one of my squishy dinosaurs and it kind of got my whole desk.
Wait, the one that
The little gator that I had? Yeah.
he was my friend.
Like, it popped kind of like when you shoot an alien in any video game, that kind of splatter effect. It just went all over my desk. So, come on now, do the thing.
I swear, what is
Thank you.
Thank you muchly.
Um, Maddie, Isabella, Rachel. I don't have your chapter 1 packet still. Okay, that was quite a while ago. I know we've had lots of interrupted schedule in between there. But I would very much like for those to be in so I can mark those for midterm. Today is the rest of my grade-a-thon. Speaking of attendance. I know y'all are in the tank. I hear the engines humming really hard, but I have to say this before I forget again. Remember, if you have missed a test, you can still get that done today. If you got an open block or even after school. But I would like everyone's grades to be as up to date as possible. Before we play coupon origami, maybe we should finish the problem. No, maybe you're just really bad at it.
Don't forget.
If you are doubting yourself, there should be two integer x-intercepts, two asymptotes of types, and maybe even something special. Maybe something special that the device we rely upon so much will not tell us. Y'all, we're closing on 20 minutes here. For problem. Okay. It looks like most of us have the graph, or parts of it. We're just kind of putting everything together right now, maybe finding our last point or two. So, we'll get started here. The first stage of every one of these has always been factor, factor, friggin' factor. Now, if we can't factor this off the top of our head, are there other ways you could break it into factors? Right? If you don't want to do split method factoring, and that is what is needed here, I need to turn that into minus 3x squared plus x squared minus 5x plus 6, because these two got x squared in common, leaving x minus 3. These have a x minus 3, x plus 2. Take out x minus 3, leaving x squared plus x plus 2. Nope, minus 2. There we go. Getting x minus 3, x plus 2, x minus 1. That split method factoring is something that I said I'm not going to make you do. I'm going to keep showing you so you know it's possible. Could I have just done synthetic division with what I feel lucky about and break it into its factors after finding that 3, negative 2, and 1 all work as zeros for the top polynomial? Okay, so you have that method available to you. The numerator becomes x plus 2, x minus 3, x minus 1. The denominator factors into x plus 2, x plus 1. So whether you factored or did synthetic division, whatever your jam was, you get the factored form. When you get the factored form, now we start seeing stuff. We've got zeros, or x-intercepts, at 3 and 1. We've got a vertical asymptote at x equals negative 1. We've got a vertical vertical, y-intercept at 3. We'll see if that's still the case after we do a thing here. And I would need to divide, where'd you go? Green. Because of my degrees on the numerator being larger than degree on denominator, I would need to divide in order to figure out what my oblique asymptote is. Before I go do that, though, your calculator will not show you the hole. There is a hole at -2, whoa, just -2. I said what I said. There we go, -2, comma. If I plug it into what's left, we'll get -5 by a -3 is -15 over a -1. Is it at -15? Wow, that's way back there. Okay. So if I'm going to find that oblique asymptote, I can take this numerator, whoa, I can take this numerator divided by this denominator and get my oblique asymptote. Or, since I'm graphing what's left, I can take this numerator divided by that denominator. I'm choosing to do that because it's going to be synthetic instead of long division. I have x squared, when I multiply this out, minus 4x plus 3 divided by x plus 1. I'll use -1 as my division coefficient. 1 goes here, -1 goes here, -5 goes here, 5 goes here, a remainder goes here, and who cares? Because I'm going to have an oblique asymptote at y equals x minus 5. So before touching the graph at all, I've got all this stuff. Remember, be honest about this. Okay? If you don't get to all of the things, if you don't have all of the things, how many things are you missing? How far off were you? Calling it a 5 out of 5 every time, or calling everything that you did wrong, whether it was atrociously wrong or not, a 4 out of 5, doesn't do anything for you. It's the test that matters. It's the knowledge that matters. Seeing all of that stuff, like a hole at -2, -15, I know that I can't use my scale as is. I saw some of you went by ones and you just got really big graphs. That's okay. I can't do that because I don't have the space. So to go out to -15y, I need at least by 3. So I'll probably do by 4 instead. Yeah. So we'll go by 4s here. How far left and right does this thing go? Will I need to go by 2s on my x-axis as well? I've got my x-intercepts for sure, but... Okay. So let's start plugging things in. We have a vertical asymptote. I'll wing it over there, but y'all have it on your graph. Vertical asymptote -1. Boop. Oblique asymptote x minus 5. So I'll need to start at -5 on my scale. That's right here. Now, if it's got a slope of 1, I don't really want to go up 1 and over 1. God, not even there. It's going to be on the line. Mine's going to look almost horizontal because of my scale, but sometimes that's just what you got to deal with. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. So mine is, Come on, Frank, it'd help if you were actually accurate. So it is oblique, even though it's really shallow on here. X-intercepts, going to have 1 and 3. So 1 and 3. Y-intercept was at 3. So about meow on my scale. Again, going by 4s. Hole at -2, -15. Back 2 down 15, so here's 16. We'll put it right about here. Do you have enough from that to make your graph without going and finding extra points? The top for sure, the bottom I might need a little bit more, but if you winged it down there on a small scale like this, I'd probably be okay with it. If you have a larger scale where you could actually see stuff, then yeah, I'd probably want to find 1 or 2 more points. But the goal is you'll have something like that and something like that. So our critical features here were you got your intercepts, you got your vertical asymptote, you got your oblique asymptote, you got your y-intercept, you got your hole. I'm assuming that the graph would be correct if you found those things. Yes, ma'am.
Did I just like, so I couldn't find anything, but if I just put like really, I knew it was gonna be a -2 because I knew it wasn't, because my thing went past that asymptote. So if I just put that really close and got it, does that work?
I'll take it, but y'all remember, how do we find the exact location of the hole? Plug it into what's left.
How would you factor the top? I don't get it.
You have to split factor it.
Yeah, but I don't know how to do that.
Then you put the numerator only into y1. What do you feel lucky about? And then find your zeros, because if you know your zeros, you can write the factors. Remember, every 0, x minus that is a factor. Okay? So this is, I mean, really, that put everything into one place. That was finding the zeros of something, whether it was by factoring or synthetic division. That was all of our stuff about rational functions that we've been dealing with. It was everything just kind of grab bagged at once. Okay, this was the KFC bowl of chapter 2. Just throw it all in one spot and say whatever. So the homie work was a long time ago. 6 days ago. Last Wednesday. Anywhere in that time, I'm assuming those that wanted to ask questions have asked questions. So we move on to the back half of 2.5, which is after the graphing, can you solve the equations? As long as you know how to factor, this stuff is no problem. Okay? We start with example 6, and I literally wonder why this is in a pre-calc textbook. This is straight out of Algebra 1. Okay? Solve. Y'all remember cross multiplying, right? Boy, that makes life a lot easier. Instead of going for common denominators right now, which is what we'll do on the next example, what if I just moved him over to the other side and said x is -6 over x minus 8? Subtract that over to the other side, or the x over to the other side, whatever your jam is. And then cross multiply. I've seen a couple of kids get kind of confuzzled over the cross multiply versus cross cancel. Y'all, if I have A over B times C over D, you can cross cancel. But if I have A over B equals C over D, you cross multiply. You don't cross multiply through a multiplication symbol. Okay? You can cross cancel through a multiplication symbol. You cross multiply through equations. So, I say negative 6 by 1 and x by the entirety of x minus 8. Getting negative 6 is x squared minus 8x. It's a quadratic, everyone to one side of the bus. And I solve it however I'm going to solve it. Are there factors of 6 add up to 8? Or negative 8? No. So where are you going to go? Quadratic formula, complete the square, what's your jam? Quitters. You do it however you're going to do it. I know y'all know how to quadratic formula. I'm going to keep completing the square. I think it's easier. Half of negative 8 is negative 4. Negative 4 squared is 16. That's the quantity x minus 4 squared is 10, solved by square roots. It's always b over 2 squared. So I'll have plus or minus square root of 10 on that side. And then I'll add the 4 over, getting 4 plus or minus root of 10. Okay. I genuinely think it's faster than quadratic formula. But kids like formulas, right? It's like the difference between I know how to cook versus I can follow a recipe card. Oh, I'm the same. I'm the same with a lot of things. I can't create my own, but I can follow instructions very well. I can't draw anything of my own accord, but I can look at something and almost completely replicate it. It's been a long time. Okay, it's been a long time, but yes, I used to have the art skills. Then life happened, and then children happened, and then my original. Take a look at your original equation. There's x on denominator. I might break the first commandment of domain. So we got to check it to make sure this is legal. Well, this is not 8, so I think I'm okay. All right, but you do have to check stuff. So, however you feel like solving these, they might be basic linear equations, they might be quadratic, they might be cubic, who knows? Actually, I know. It's going to be linear or quadratic because these are taken straight out of the Algebra 1 textbook. Move something to the other side, cross, multiply, solve. Double check your answer. Because yes, it's possible that you solve a rational equation and you get no solution because you followed all the rules and the answers were still illegal. Check me before I wreck me. I walked away without putting question marks, and I did mental math before launch.
Check my -8 for the first time.
4x plus 12 equals 20. Subtract 4x equals 8.
Oh.
Divide.
Let me look at this. 32. Did I do it wrong?
You can't just move -4 over there. You have to add it over.
Oh.
You don't know me. Okay. Yes, these ones are fairly straightforward because I'm allowed to just add 4 to the other side. Cross multiply, getting 4x plus 12 is 20. Subtract. But then double check it. Is that legal? Okay, 2's fine. I'll already got that on the other side, so cross multiply and get 6x minus 12 is 9x. -12 is positive 3x. Divide, x is -4. Is it legal?
Yes, it is.
Okay. So just double check for extraneous solutions. If there's an absolute value, if there's x on denominator, if there's an even radical, if there's a logarithm, I have to check to make sure that I haven't broken math law with my answer. It's like, have you ever seen those kind of meme math proofs that at the end of it, it says 2 equals 1? And they say, ha ha ha, math sucks. Or where is your God now? Like, 2 equals 1. And they did the math, and the math makes sense. It's because somewhere along the way, they divided by an expression that was equivalent to 0. But because it was all in alphabet form, no one noticed. It's kind of like, look over here while I palm this coin. Okay? You have to check that. Now, also straight out of the Algebra 1 books, but it sounds like everyone should have done this in Algebra 2, right? You were last semester or last year? Oh yeah, you were the one that was way back then. Okay. So you might not have seen this since like 2019. So this is going to be no different, uglier, but no different than if I said 5/3 plus 2/7. I'm not allowed to put those together because the pieces are not the same size. I have to make them the same size by doing common denominators, right? So the same thing's going to happen here, but oh, sweet Jeebus, I swear, if any of you tries to freshman this and say, I'm going to subtract 2 here and subtract 2 here.
What? How does that?
Because then it's x minus 4. I have had a kid try to do that in Algebra 2. Okay, no, bad. All right, no freshman math. Please tell me you're just trolling. Okay. All right, this is a difference. Because it's a difference, I have to work with its entire expression as a factor. So when I say to get common denominators, what are they missing? This is missing an entire x minus 4. This is missing an entire x minus 2. Okay? And ironically, this happens to factor into x minus 2, x minus 4. It doesn't always work out that way. I'll just tell you, most of the examples in books are that way. It's not always like that. Okay? So, now I'm going to end up with a 4 over x minus 2, x minus 4 equals a 3x squared minus 12x plus 2x minus 4 all over x minus 4, x minus 2. All I did was distribute my numerator. I haven't combined them yet. I just distributed. Okay? I can't just take it away. It's like a little kid. If you just take their toy away without explaining anything, you're going to get a much bigger tantrum than if you explain what they did wrong. Speaking in 5 and 3-year-old parent here. If I just grab it and put it on top of the fridge, whoa, here come the fireworks. You have to explain. Why can my denominator go away? No. Okay, now we're gonna see this again when we do our log and exponential equations. It's a difference between same base theory versus the definition of logs. I can logically look at this and say thing over A equals other thing over A. Thing and other thing must be the same by logic. Or what if I multiplied the whole thing by x squared minus 6x plus 8? It cancels. That's why it goes away. It doesn't just yeet out of existence. When I multiply by that denominator that they now share, it goes away. They cancel. Okay? They cross cancel because this is x minus 2, x minus 4. All of these pieces will cancel. It's not just that they poof, it's I multiply by that same denominator now that they all share it, and they all cancel out. Okay? Okay, now I write my numerator stuff that's left over. Getting 4 is 3x squared minus 10x minus 4. I see that I have a polynomial. I solve polynomials by putting everything to one side and factor if I can. In this case, I'll have 3x squared minus 10x minus 8 is 0. This is factorable. Do we got the mental mojo after being in here for a couple of months? You don't have mojo, your calculator does. Yo, the only way that you're going to get 3x squared, because it's prime, is with a 3x and an x. Could you mentally go through the factors of 8 to get a negative 10 in the middle? Okay. Then could you AC method? Factors of negative 24 that add up to negative 10 are negative 12x and 2x. Taking out a 3x, leaving x minus 4. Taking out a 2, leaving x minus 4. Leaving x minus 4 and 3x plus 2. It's a quadratic. You solve however you want. You can complete the square. You can quadratic formula. You can factor. If it's a rational number, you can even jam it into a calculator and go calculate 0. You better have the work to back it up.
So
Okay.
when you cancel the bottoms or the denominators, you can only do that if they're set equal to each other. Right?
Yeah, it's just like if I had an equation where everything was over 2, 8, and 4, I just multiply the whole thing by 8 so I don't have to deal with denominators.
But if they're not, there's no equal sign. You can't do that.
Correct, but we're specifically dealing with equations, so we're going to have this. Okay, that is correct. Like if you just have an expression, not an equal sign, I can multiply both sides of an equation, and then I keep the balance. I can say, all right, everyone on this side of the table and everyone on this side of the table, I am going to triple your mass. Well, the teeter-totter is still balanced, okay? But I can't just look at no balance and say, I will triple your mass. He's like, huh? There's nothing to balance it with, right? I can't just look at an expression and say, times 8. But why? It'd be like me looking at, I don't know, Holly and saying, shorter. You can't just do it because you feel like it, okay? So, yes, I will have answers of 4 and negative 2/3. Or do I? Because when you go back and look at the original, 4 is illegal. So I have to get rid of 4 and say only negative 2/3 because thou shalt not divide by 0. So you need to get a common denominator. You need to distribute combined like terms. Instead of cross multiplying, that's the way the book does this, they cross multiply and get a pair of quartics. But then a bunch of stuff cancels out. Complete square. X squared minus 10 thirds x is 8 thirds. Variables on the left, constants on the right, divide everything by a. Half of negative 10 thirds is negative 5 thirds. Negative 5 thirds squared is 25 ninths. Need common denominators, put them together, turning that into 24 ninths. Put them together, I get 49 ninths is x minus 5 thirds squared, half of that. Solve by square roots, I'll get x minus 5 thirds is plus or minus 7 thirds. And it still works. Because 5 thirds plus 7 thirds is 12 thirds, or 4. 5 thirds minus 7 thirds is negative 2 thirds. So you can solve the quadratic however you want. But you better go back and check for those extraneous solutions. All right. Start with 1. Start with just part A. Let's make sure we got it before we just say doable. Okay, get your common denominators. First thing I would do is that quadratic, I'd factor it. Just in case. It doesn't always work out that way, so don't just plan on it, but most of the examples we will see will work out that way. Okay, you can absolutely shorthand those first couple of steps. Like, if I was just writing down the problem, I'd write the denominator factored anyway. Get my common denominators, and I just understand I'm going to multiply by that quadratic to make the denominators disappear. Uh-huh. They don't just poof. They cancel out, leaving me with 2x squared plus, minus 12x plus 3x plus 9 is 27. I see that I have a polynomial of some sort, so I will combine like terms, put everything on one side in the bus, getting 2x squared, smash those together, negative 9x, subtract 27 over, getting a negative 18. Solve the quadratic however you feel like. For me, only way I'm getting 2x squared is with 2x and an x. Rep through the factors of 18 quick like, and say a negative 6 and a positive 3. That'll get me negative 12 plus 3 is negative 9 in the middle. So I end up with x is negative 3 halves when I set equal to 0, and x is 6. But then I go back and look at the original and say, nah, dude, 6 don't work. Okay, breaks math law. So you don't need to fill up an entire page worth of work for this. You can kind of shorthand those first few steps. All right. Cross out 7b, I want uglier. Let's go to the next one and go to 9. As long as they don't represent something specific in a formula, if you want to use the problem with a different variable to make life easier, absolutely. Because P's, B's, Q's, they all just look like 9s and 6s anyway. S's look like 5s, 2's look like Z's. If you just want to replace those with X's, go ahead. If you ever write X equals in a problem like this just out of habit, I ain't gonna fault you for it.
Why did they change it?
Just to reinforce the idea that a variable is a placeholder. You could do it however you want. A variable is just a placeholder.
Why would you do that?
Because a variable is just a placeholder. It can be whatever we want.
Have fun just drawing that many smiley faces. Because now you have to stick it with the whole problem.
Oh, now we have to, if you're going to use a bit, you better use the bit for the whole show. All right, so this one is missing a smiley face -1. This one is missing a smiley face -1. This one needs a smiley face +1. Smiley face +1. This factors into the same thing of smiley face +1, smiley face -1. See, the hand is going up to start the X. And if I multiply by that entire quadratic, then it's going to cancel out anyway. Okay? The X's are inclusive. No, I'm not keeping the bit up. That's stupid. Then I'm going to have... Yeah, I did. Oh, last minute I switched to the smiley face. I was going to put the turd up there instead. Takes longer. All right. So I have 2 of these squared. 2 of them minus 3 of them is 1 of them. But I will add 1 of them over, making 2 of them. Subtract 15 over, getting -12. Factors of 2 smiley face squared are 2 smiley face and smiley face. Oh yeah, Chase is gonna have to watch this. Run through the factors of -12. That will get me a 2 in the middle. In this case, we're gonna have what? -3, 4. So +3 minus 4. You wanted me to keep working with smiley faces.
It's not the smiley face. I just did 3 times 1 equals 1 instead of 3. Wait, what if you did?
Yeah, that's also what I got.
Because right at this line, did you see that you could just divide by 2? That's why this has a 2 that can come out. -2 plus 3 is 1. Add 1 to the other side.
But doesn't that work?
Well,
6 and 2. So you have +6 minus 1.
So yours doesn't work.
What way? I'm pretty sure
Yours
this does
doesn't
though.
work.
Couldn't that be? Are there 2 answers?
no.
It doesn't.
You know, if this is 2x squared plus 2x minus 12, it's also x squared plus 1x minus 6. I don't know where you're getting your 6 from.
Well, because factors
That would lead...
6 and 2.
2x plus 6x minus 2.
Boy, that was a lot of letters and numbers at once from 3 people. What?
Here, just come look.
Yeah.
And and I did the smiley face method, and it works.
Hey, those are X's.
You're not getting 6.
What do you mean?
Who said 6? Someone said you're gonna get 6.
No, I'm saying you use 6 and 2 instead
Yeah.
of
Okay,
4
we're getting
and 3. And I did the same.
So
6 minus 4 is also
2.
a 2x or 2 smiley face in the middle. It's because the 2 can come out.
Okay. So it's correct 2. But it doesn't
It can go into either one of those factors.
Right, but I don't get the same answers as you.
You should.
You got -3.
Yeah.
Oh yeah, never mind. I definitely. Sorry.
What are you on?
Okay,
You
we're
do
good.
not need another
You're good.
person.
That was a 5-minute derailment, child.
Well, I don't understand what's happening.
Okay. You see how at this line you can factor out in 2? You see how this factors into x plus 3 and x minus 2. If there's a 2 out in front of it, that means this could have been written as 2x plus 6, x minus 2, or it could have been written as x plus 3 with 2x minus 4. They're the same thing. So anyway, we're at a 2 and a -3. Go back to the original. Are those legal? Yes. Fired. All of you. Everyone here is fired.
Really? About?
No, not even close. Blah, blah, blah words. How many of you have taken, what is it? Not this year. Banton had a DC electronics class. Anyone take the Banton electronics? So then the last place you probably would have seen this was physical science. Okay. When you talk about, remember, resistors are things that are supposed to slow down the amperage. You get formulas for them. You probably remember there was a whole bunch of I's, P's, and R's all over the place. And you would be given X amount of things and just plug and chug, solve basic algebra, right? Well, here you go. I got a diagram. It's got parallel resistors. We have formula. Formula tells me my total equivalent resistance. R sub 1, remember that's not R to the first. It just means the first R. R sub 2, R sub 3 means the second and third resistor, not R squared or R cubed. Those are subscripts. Says R sub 1 is twice the resistance of R sub 2, R sub 3 is 20 ohms. If they just give me that stuff, then this becomes a lot easier to work with. I say 1 over R is 1 over R sub 1 is twice the resistance of R sub 2. So how about I just replace it with 2 R sub 2? Plus 1 over R sub 2. And it says R sub 3 is just 20 ohms. Suppose the equivalent resistance is equal to 10 ohms. So I replace the total equivalent resistance with 10 ohms. What I've done is take this equation that had 4 different variables in it, and now it's condensed down to a single one. I'm still going to solve the same way I want to find. Now, you only need to combine on this side, and then you could cross multiply. Or you could get everything to the exact same denominator, so you can multiply and just make the denominator go away. Your choice. Combine stuff on right, cross multiply, or everything same denominator, get it out of there. They're going to have the exact same result at the end. Which one seems better? Everything same denominator at once, or just the right side gets same denominator solved by cross multiply.
Doesn't matter.
Okay. So if I look at this one, what's it missing? For a total, okay, what's the least common denominator of the right side? It's missing 10, right? 2 r squared 20, altogether 20 r squared. R sub 2 is my least common denominator. You're missing a 10. What's this guy missing? 20. What's this guy missing? R sub 2. Getting 1 over 10 is 10 plus 20 is 30. 1 times R sub 2 is that. Over 20 R sub 2. Cross multiply solve. Right? 10 plus 20 is just 30. So if I take this times 10, we got 10 R sub 3 is 20. So I get 10 R sub 2's is, oh wait, 10 R sub 2's plus 300. Equals 20 R sub 2's. Subtract 10, divide by 10. R sub 2 is 30 ohms. Then go back to the other ones. They said if R sub 1 is twice the resistance of R sub 2. So R1 is going to be this, R sub 2 is this, R sub 3 is this. They straight up told me this is 20 ohms. I just found out this was 30 ohms. And then it said R sub 1 is twice the resistance of, so 60 ohms. Remember, resistance just slows it down. It's like you can get in a lightning bolt, it's not the voltage that kills you. It's the amperage. It's how much it's forcing through at one time. The difference between someone pouring water on you for a half hour versus someone dumping an entire payloader bucket of water on you at once. Okay? It's the amount of it that gets you. Resistors slow that current down. So, same thing. They're just saying, hey, you can do this in context. I know how to solve a rational equation. Can you solve the rational equation in context of a problem and answer questions? Be interesting to see if Daggett brings back DC electronics next year or not. It used to be in every other year class. Like kids would tear apart a bunch of stuff and build their own computers. It was pretty cool. Solder your own circuit boards. Like, it was cool. Okay, first up they say current is 1. Replace current with 1. Get common denominators.
You just like subtract the t over and then cross multiply.
You would have 1 minus t,
Over 1
and then cross multiply, getting your quadratic, yeah?
So I did that, but it doesn't factor.
Yeah, mine doesn't factor in.
Well, I'm pretty sure mine don't either, because cross multiply, we got a negative t squared plus 10t plus 1 is 10 minus t. If I put everything to one side of the bus, here, I'm running out of room. We're going to just move all this up. If I bring everything over to the right, we'll have t squared, subtract 10t is negative 11t, subtract 1 is 9. And last I checked, there are not factors of 9 that add up to negative 11. So you're going to solve that however you're going to solve that. Okay?
That'd be negative 1.
Why are we adding 1 for 1? Because that's the one.
I moved everything over that way. 121, 4, negative 36, negative 36, negative 15, 85. Getting t is nasty. 11 halves plus or minus square root of 85 over 2. Square root of 85 is going to be 9 and change over 2. We'll call it 4.6-ish. 5.5. So 10.1 and negative number, and the negative number has to be thrown out. Right? Oh, that's 4.6-ish. 5.5. About 0.9 and 10.1. Ballpark? Anyone? Maybe?
10.2 or 10.12 and 0.85.
There you go. Okay. You got to be able to put it all together. You notice we're halfway through now. Said this how many times? You have all the skills. Right now we're just expanding on them and getting ready for the next level. Okay. So we did rational graphs, we did rational equations, we did polynomials. Then, I believe Kate said at this point she was going to run away. Because now we're going to throw Pac-Man in the middle of there. Our inequalities.
Shade brown.
No.
Oh, no shade. I like the color.
Okay. So right now, if I looked at this graph, like just ignore everything else on the page, and if I asked f of x equals 0, when does that happen? At -4, -2, 2, and 5? Okay, because that equals 0 on the x-axis. What's going to change now is if I ask, where is f of x less than or equal to 0? Well, where is the graph below 0? Here and here. So I would list those as an interval. I would say from -4 to -2, union from 2 to infinity. Okay? Because the only places that a polynomial graph is going to switch from greater than 0 to less than 0 is at 0. So you're still going to find the zeros the way you have been. The difference now is I have to ask, is it above or below the axis? Also, how does this change if I say f of x is less than 0? It can't be equal to. So now all of a sudden, this has to be an open circle, an open circle, an open circle, and an open. Oh. If that's an open circle at 5, because it's not equal to 0, then I have to go from -4 to -2, from 2 to 5, and then I have to cut the 5 out of there, going from 5 to infinity. Because it can't equal 0, the one spot where it hits 0 and bounces off, I have to exclude, because that's like asking, hey, are you shorter than yourself? Okay. So we're going to find the zeros like we have been. We're just going to ask above or below the axis, parentheses or brackets, include or not. Okay? So we start with, how do I solve a quadratic? Everyone equal, set and equal to 0. Everyone on one side of the bus, we go x squared minus 6x, add 3. Solve it however you gonna solve it. Quadratic formula complete, the square, calculator mojo, factor. Now, I would still solve by setting equal to 0. This is still going to have an x-intercept at 9 and an x-intercept at -3. That's still going to happen. The question is, on that number line, if I have a x-intercept at -3 and an x-intercept at 9, when is it above or below that line of x equals 0? Or sorry, y equals 0? Very simple with these ones. Is that parabola happy or sad? Right? It's a positive parabola. So if these are my zeros, doesn't it have to do this? Now I can do that any number of ways. A, I know what the function looks like. B, I could actually just graph it. C, I could plug numbers in. Like, what if I plugged in a -4? -4 squared minus 6 by -4 minus 27. 16 plus 24, 40, minus 27 is 13. Is 13 greater than 0? Yes. So it would be positive in that region. I could plug in a 0. 0, 0, -27. Okay, it's going to be negative in that region. I could go plug in a 10. It'll be positive in that region. So you can test in those intervals. You can look at the graph, or you can just know what the general behavior of the graph is going to look like. So when they ask, where is this greater than 0? It was back here from negative infinity until I hit negative 3, parenthesis or bracket. It was greater than 0 back here. It was greater than 0 over here. So along what x's is this thing greater than 0? And then again from 9 to infinity. It's along what x's are my y's, or the output value of the function, going to be greater than 0. Okay, I got the graph over there just in case you felt like graphing it. But the general gist of it is, y'all, if I saw this like so, with a vertex way down here, and then I asked, where is this thing greater than 0? I'm no rocket surgeon, but I'm pretty sure that from here to here and from here to here, that's where it's greater than 0. Okay? But I do want, at a minimum, some sort of like number line or something to say, I understand where this thing is positive or negative. Okay? So go and solve these however you're going to solve it. But then you got to ask the question, is it less than 0 or is it greater than 0 at those spots? Said you solve them however you want to solve them. I would cube what? Okay, the alligator, Pac-Man, the shark, whatever you learned. I was big on Pac-Man because you could just draw him right there. But however you did it, okay. We want alligator. Oh, he has no bottom teeth. There we go. So however you did it, when I say this is less than 0, I have to find the zeros because that's where I determine where it's greater than or less than the 0. So where is this thing less than 0? If I look for where is my parabola greater than the line y equals 4, it's going to be the exact same as if I translate that down to 0 instead, because the entire parabola will move with it. Okay, you're going to have the same numbers. How many of us subtracted 4 and then x squared minus 8x plus 16 minus 4 is 0, x squared minus 8x plus 12, getting x minus 6, x minus 2, getting 2 and 6. Okay, you're going to get the same thing. No matter what, you are going to get the same thing whether you set it equal to 4 or set it equal to 0. It's just normally it's easier to set equal to 0 because that's how we've been solving everything. Okay, this one is less than 0 from -7 to 2. This one is greater than 0 from -infinity to 2, and then again from 6 to infinity. Suppose I should do this. There we go.
So you have to like write f of x is greater than 0. Or do you just write the...
No, the intervals are the solution. In these regions, this inequality will be true. Okay? So, tomorrow we'll finish this off. Reminder, tomorrow is, I know not everyone listens to the announcements, tomorrow is advisory day. Y'all got the career fair going on during Spartan time. It goes in waves. I want to say it's like 150 seniors, like 210 or something juniors, 230 sophomores, something like that. But it's a career fair, y'all. You're going to have local businesses. You're going to have tech schools, military recruiters, free pens, keychains, and flashlights. Okay?
I want this shape.
So,
Is the University of South Dakota going to be there?
most likely,
Because I want one of their pens.
you will probably see all the in-state colleges and universities there.